Okay, so just like on the last one, we have our equations that we know we can do algebra to solve. Boop, boop, boop. You could just, square root both sides, add 1 to both sides, but let's not do that for this one. Let's use the graph. So to figure out where this parabola equals 4, we're asking at which x values is the output 4, which is the height. So the height of 4, the book always recommends you actually draw a full line, but I'm going to say when I draw this graph, it's at a height of 4 in 2 different places. The parabola goes down here, and right at this point, it's at a height of 4. And comes down, goes down, 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 and then it comes up, 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 up. And then here, it's also at a height of 4. So if you'd like to draw the line and intersect them, that's fine. But what 2 coordinate points are these? This looks like 1, 2, 3, 4. And this looks like -1, 4. So what it's asking here is for which x value is the output 4? And the answer is -1 and 3. If you would like to use the graph, you just have to solve for x. So remember, the x values are down here. X is -1, x is 3. Those are your 2 solutions. Now, if you don't like doing it on the graph, that's perfectly fine. You've been taught how to square root both sides, and then you get x minus 1 equals +4, or x minus 1 equals -4. And when you add 1 to both sides, you get the exact same thing. So it's up to you which method you would like to use. But it's a good thing to know that that's what we're looking for when we're solving when it doesn't equal 0. When it equals a different number, we're looking for that height. So for this one here, I wish I had a different colored pen, and actually I do have these markers next to me like I always do. I'm going to use this green marker to see where this parabola is up at 5. So here's 5, and it looks like here and here. And you might notice, like I just noticed, that these are not whole numbers. So for this one, we are hoping that we see, okay, well, the other one is 2 from the axis of symmetry, 2 from the axis of symmetry. It's up at a height of 4, 2 and something, minus 2 and something. So you could either guess on this, and it asks you here to just think about the fact that they're symmetric. But I'm going to say this symmetry over here, I can just use algebra to solve this. So either x minus 1 equals the square root of 5, or x minus 1 equals negative the square root of 5. So here's where we get into our first exciting way to write this. Now I've written them into separate what are these called? Equations so far, separate solutions. And if you add 1 to both sides, you are going to get something ugly that looks like the square root of 5 plus 1 or negative square root of 5 plus 1. Now, please leave them like this. You are going to have a lot of square roots happening in this section of the book, and you know that this is a decimal you can find on your calculator, and if you would like, it's a decimal that goes over here and over here, but just know that this is fine. You can box this as your answer, and you will still get it right, or you can find the decimal point. So determine the exact and approximate solutions for each of these equations. Here are your 2 practice problems, where exact means keep the square root, approximate means turn it to a decimal. So right here, I only gave you the exact solutions. The square root of 5 is 2 point something. So if you use a calculator, you can find the approximate solution. 1 plus 2 point something is 3 point, I literally don't know, 2. And then this one would be negative 2 plus 1 is approximately negative 1.8, I don't know. Use your calculator, but they want you to find both solutions. All right, there's your work.